Hi students, good morning. Our today's point is movement of inertia of a disk. So write down this point. Movement of inertia of a disk. This is our today's point. Movement of inertia of a disk. Write down this point, movement of inertia of a disk. And the question will be asked on this point is also IMP question. Denote it as IMP. And write down this question. Derive an expression. Derive an expression for M.I. of a derive an expression for M.I. of a disk about an axis passing through its a center of mass, and perpendicular to its plane. This is our question. This is our today's question. Derive an expression for M.I. of a disk about an axis passing through its center of mass and perpendicular to its plane. We know that the answer will be expressed in 3 points. First point is its a consideration. So write down our answer, and first point is consideration. Now we know that we are going to consider a disk of mass m and axis is passing through its center and perpendicular to its plane. So consider this disk. So our consideration is consider a disk of mass capital M and radius capital R. This is our consideration. Consider a disk of mass capital M and radius capital R is rotating about an axis passing through its center of mass and perpendicular to its plane. This is our consideration. And so show this consideration in the diagram, and the diagram is our second point. Suppose that this is a disk of radius capital R. This is a point and it is the center of mass. Suppose that here is an element This is this is a center of mass. This is a radius, and this is our axis. Show the element as a ring. Draw this diagram. This is our second point, and it is a diagram. Now after the diagram, we know that third point is notation. So write down the third point. Let already m is the mass of the disk, so sigma is equal to mass per unit area is the mass per unit area of a disk. Let sigma is the mass per unit area of the disk. Now our main point, and it is a fourth point. Now if this disk is supposed to be made from concentric rings, then consider a ring of radius small r is a element, is its element having mass dm. Suppose that a disk is made by, suppose that a disk is made by concentric rings, made by concentric rings, then consider such a ring of mass dm and radius small r, and the mass dm is expressed as dm is equal to sigma is the mass per unit area into area of the ring, and it is 2 pi r into dr. This is area of a ring into sigma is equal to total mass of the ring, and therefore mi of a ring, therefore mi of a ring about a given axis of rotation is, about a given axis of rotation is IR is equal to R square into dm. Therefore it is R square into a sigma into 2 pi r into dr, and therefore IR is equal to sigma into 2 pi into a r cube into dr. This is mi of a ring about a given axis, and if a ring is an element, then the mi of a disk is, therefore mi of a disk about a given axis is, therefore mi of a disk about a given axis is, and it is I is equal to integration of 0 to capital R into IR. So it is equal to 0 to capital R 2 pi into sigma into R cube into dr, Now we know that 2 pi sigma is constant. Write it as a sigma into 2 pi, and in the integration it is 0 to r cube into dr. We know that integration of r cube is equal to r raised to 4 from 0 to capital R, and it becomes 2 pi into sigma, and in bracket it is r divided by 4, r cube divided by r raised to 4 divided by 4. So it is capital R raised to 4 divided by 4, and it is equal to pi into sigma into bracket r raised to 4 divided by 2. But we know that sigma, substitute the value of sigma. Sigma is equal to m upon pi r square and into r raised to 4 divided by 2. And therefore our main equation becomes I is equal to pi to pi mr square divided by 2. This is the required expression. This is required expression. This is required expression.